Alrighty, this is Chapter 2, Section 3, solving multi-step equations. And just like the title says, we're going to solve equations with multiple steps. Now, the key to solving a multi-step equation is to undo every operation by working backwards. So think the reverse order of operations. Let's take a look. So in this equation, we have 11x minus 4 equals 29. First, take a look at the side with the variable, that's the left-hand side. And at the very end of order of operations, the last things we would normally do are addition, subtraction. That's the first thing we want to take care of here. So you can see how we have this whole number here, this minus 4. The opposite of minus 4 is plus 4, so we're going to add 4 onto both sides. The minus 4 and plus 4 cancel. We're left with 11x's. And on this side, 29 plus 4 is going to be 33. Now, we're not done yet. We still don't have x isolated. X is being multiplied by 11, so to get rid of this coefficient, we're going to do the opposite of multiplication, which is division. Remember, a fraction bar symbolizes division, so this is 33 divided by 11, 11 times x divided by 11. Those 11's cancel. So we're left with x on the left-hand side, and x equals 3. Now, one thing I want you to notice also is how everything is lined up for the most part. Your work should be like that as well. It'll make it a lot easier to check your work, to check for mistakes, and hopefully this will help you get things right. Now, in this problem, the first thing we want to do, because you remember with fractions, we're going to take care of the, any division at the end. So, first thing we want to do is we want to take care of this 8. The opposite of dividing by 8 is multiplying by 8. So I am going to put this entire thing in a grouping symbol, parentheses, and I'm going to multiply by 8. And I'm going to do that on both sides. Multiplied by 8, divided by 8, they're opposites, so they cancel. We're left with a plus 7 equals, and 5 times 8 is 40. The opposite of plus 7 would be minus 7. Cancels on this side, we're left with a, and on this side, 40 minus 7 is going to be 33. Now, here's another example. This one has a fractional coefficient. So, the end of the order of operations is addition and subtraction, so we're going to take care of that first. The opposite of minus 25 would be plus 25. Cancels on the left-hand side, leaving 2/3 p. And on the right-hand side, 115 plus 25 is 140. Now, remember, in order to get rid of a fractional coefficient, we're going to multiply by the reciprocal. And multiplicative inverse tells us that this is p. And on this side, we have 140 times 3/2. So, when we multiply this, you have a couple options. If you want to, you can divide the 140 by 2 and then multiply by 3. This would give you 70 times 3, which is 210. But what I think most of you would like to do is turn this into a fraction as well. Remember, you can make any whole number a fraction by putting it over 1. And we multiply straight across on the top, 140 times 3, which would be 420. And for the denominators, 1 times 2 is 2. 420 divided by 2 is going to be 210. Okay, so the next thing we need to talk about are consecutive integers. Consecutive integers are integers in counting order. Now, I'm sure that most of you can count consecutive integers without any issue. 4, 5, 6, 7, 8, 9, and so forth. But I'm also going to show you how to count integers, consecutive integers, using symbols. Take a look. If I assume that the number 4 is equal to the letter n, let's just say n, it stands for number, then the next consecutive integer would be n plus 1, the next n plus 2, the next n plus 3, and so forth. So what I'm saying is with symbols, consecutive integers can be written like this. I'll prove it to you and make sure that this makes sense to you. Again, if n was 4, I'm going to replace the variable with 4 right here. If n equals 4 and I replace this variable with 4, look what I get here for this integer, 4 plus 1. 4 plus 1 equals 5. That's what I have here. This was 4. That's what I have here. Let's test it for this one. Again, n equals 4, and 4 plus 2 is 6, which was the next consecutive integer. Here, n is 4, and 4 plus 3 is 7. So I proved to you that these symbols work for counting consecutive integers. Now, if you're counting consecutive even or odd integers, the symbols are a little bit different. Let me show you. Here we have a set of consecutive even integers. Now, notice the difference. Here, we're going up by 2 versus here going up by 1. So that's going to be reflected in the symbols as well. The symbols this time, again, we'll start with n, but next we're going to have n plus 2. That'll be followed by n plus 4, and then n plus 6. Notice that the numbers we're increasing n by are going up by 2. Let's test it out. If n equaled 2, this would be 2. It checks out. If n equals 2, 2 plus 2, 2 plus 2 equals 4, it checks out. If n equaled 2 here, 2 plus 4 is 6. And if n equaled 2 here, 2 plus 6 equals 8. So, as long as the first integer you start with is even, these are the symbols you use to count consecutive even integers. Likewise, if you want to count by consecutive odd integers, as long as the integer you start with is odd, you would follow the same exact pattern with your symbols. Now let me show you an example of how we could use this with a problem. Now, let's take a look at this problem. Find 3 consecutive odd integers with a sum of negative 51. Now this is why symbols are great. I don't know which integers, which 3 consecutive integers have a sum of negative 51. But I do know that if the first integer is n, then the second integer must be n plus 2, and the third integer must be n plus 4 from the pattern with symbols that we just spoke about. Now it says the sum of these has to equal negative 51. So the sum of these 3 integers, the first, second, and third, maybe if I use grouping symbols it'll be a little easier to see, first, second, and third, I know that that has to equal negative 51. So from here, I just simplify. Like terms, I have 3 n's, so I'm going to write that as 3n. And for the whole numbers, I have 2 plus 4, that's going to be positive 6, and all that equals negative 51. Well, now we have a 2-step equation to solve. First thing I'm going to do is get rid of this plus 6. The opposite is minus 6. Here it cancels, and I'm left with 3n. On this side, negative 51 minus 6 is going to be negative 57. And now I want to get rid of this coefficient. The opposite of multiplication is division. So I'm going to divide by 3 on both sides. It cancels on the left, and I'm left with n equals, and positive divided by, or negative divided by positive is going to be negative because the signs are different. And 57 divided by 3 is going to be 19. Now, we're not totally done yet. That's just what n equals. The question was to find 3 consecutive odd integers. So we know these are the integers, so let's do a little bit of substitution. N equals negative 19. So the first integer, which is n, is going to be negative 19. Now the next integer is n plus 2. So this would be negative 19 plus 2, and that would equal negative 17. The third integer is n plus 4, so this would be negative 19 plus 4, and that would equal negative 15. So the three consecutive integers that have a sum of negative 51 would be negative 19, negative 17, and negative 15. And you can always add these to double check it if you want to. And if you understand that, you understand everything for this lesson. See you in class.